Hello, everyone. In this video, I am going to be walking you all through testing distinguishability within the context of the common fate model. So in a previous video, I had gone over the common fate model, and you'll see the syntax here. And so what we are going to do is we are going to build on that model by, again, testing distinguishability. If you're familiar and watch the APIM videos, then you're probably familiar with the idea of distinguishability. But oftentimes, especially when we're working with like heterosexual couples or working with parents and children, and those are our dyads, we have kind of theoretical indistinguishability. So where we can say, mom is, dyad number one and child is dyad number two. And so that's really helpful. And, there's really good kind of, again, theoretical rationale for that. But we also need to empirically test whether or not that theory is supported. Because if they are, in fact, indistinguishable, you can kind of interchange them a little bit, that actually has implications for model syntax, for the number of parameters you estimate, and ultimately for your statistical power, where we generally need fewer dyads for indistinguishable dyads compared to distinguishable in order to achieve a specific level of power. So there are potentially important implications. And so again, in this video, I'm going to build on this first model that I previously run in the video to test indistinguishability. All right, so briefly, I'm using these two packages. I'm using Lavaan to run the structural equation models, and I'm using Haven in order to import my SPSS data file. And from the previous video, you will see the syntax here, and this is again the baseline common fate. And this is not testing distinguishability in any way. This is essentially just the most basic common fate model that you can run. All right. And so if you are unfamiliar with the common fate model, I would encourage you to watch that previous video. Otherwise, we are going to move on to the distinguishable model. All right, so I'm going to need to run this real quick because we are actually going to be adding some syntax where we're going to statistically compare the two models. So in the indistinguishable common fate model, there are several things that we are going to do. So the first is you'll see nothing is different here, right? In the structural portion of the model, your regression coefficient's the same. In the measurement portion, where you're constraining the factor loadings to be 1 across all your indicators, all of that is identical, all right, to the previous model. Where we begin to get when we begin to constrain different pathways, we are going to start at the covariances. So in the common fate model, you have those, again, the two latent variables that are indicated by each dyad member's reports on the construct. And then you have covariances across the two common fate variables. So you have male reporter on the common fate variable 1 and male report on common fate variable 2. And there's a covariance there. And you have the same thing for women in this example, since we're using heterosexual couples. So what we are going to be doing to establish distinguishability is we're going to constrain those covariances to be equal to one another. So the extent to which the residuals of male reports correlate with one another are going to be held constant to the female reports, their level of residual covariance between their reporters. And this, again, these residual covariances really account for kind of like reporter effects, variation that is unique to the males and unique to the females. And again, we're going to hold that constant. Right. The second area in which we are going to place constraints is on the item intercepts. And so you will see here that we have the item intercepts for relationship quality and for relationship mindfulness. And you'll see I have added, again, the labels in order to tell Lavaan, in order to hold that constant. And I also did that up here with relationship mindfulness. Again, if you use the same labels, that's going to tell Lavaan to hold those pathways, those parameters to be equal. And so for covariances, it's a it's pretty straightforward. When constraining intercepts, it can feel a little wonky since you're using a regression coefficient, but this is how you would do that within the context of Lavaan. And if you just want to estimate the intercept, you would just have this line of syntax. You do your outcome variable and then regressed onto 1. All right. But we do not want to do that. So we want to keep that label in there and also be very careful that you constrain the intercepts across the dyad member to be equal, but only on that within a single latent construct, within a single common fate latent variable. So we don't want to constrain the mean of relationship mindfulness for males to be the same as relationship quality for males, right? Because they're two different variables, they're measured on two different scales. That wouldn't make a whole lot of sense, and it's going to send your model all out of whack. So be sure you are constraining the item intercepts on the same variable just across dyad members, and you're doing that for both variables. All right, and then I'm actually going to add one more piece of syntax here. We are going to do the likelihood ratio test. And so we are going to add in fit.1, which is the fit from the first model, which is why I needed to run the common fate model. And then we're going to run this one right here. All right. And so this is essentially going to be our chi-squared difference test because we are imposing 3 additional constraints. So the baseline common fate model has 1 degree of freedom. So there's we are placing essentially 1 restriction on the model, right? And so in the indistinguishable example, we are actually going to have 4 degrees of freedom, right? So we have 1 degree of freedom given for constraining the residual covariances to be equal, right? So before they were male had their own and female had their own, but now we are essentially kind of taking a dyadic average. It's not exactly the same thing as a dyadic average, but that's kind of how you can think about it. So we're only going to actually estimate 1 parameter, and it's going to be the same for both male and female. So that gives us a degree of freedom. The same thing for the item intercepts. We have 2 item intercepts. We are telling Lavaan you can only estimate 1. We're going to take essentially a dyadic average, and we're going to only have 1 parameter that is actually estimated, and it's just going to apply to both dyad members. So we get an additional degree of freedom. That brings us to a total of 3. And finally, we are going to do that for relationship mindfulness as well, which brings us to again, a total of 4 degrees of freedom. Right? So we can go ahead and we can run this model. All right. So this is the baseline common fate up here. This is the model I ran in, I believe, in the first video. All right. And so we have 1 degree of freedom. So we're good to go here. We look at our fit. Everything looks fine. So we're going to scroll down to the indistinguishable model. And, just looking at this, I can tell you that it's going to be non-significant because 3 degrees of freedom were added to the model. And so the critical values, I don't know exactly where it is, but it's going to be somewhere around perhaps 6 or 7, somewhere in there. And our chi-square value is only 1.93. And so before it was 0.735. So by imposing these 3 additional restrictions, our chi-square only went up by like 1.2 or somewhere in there, which is not a lot. And it's going to be substantially below that critical value. So we can say that these the dyad members here, although theoretically distinguishable across gender, are not empirically distinguishable from one another, and they can kind of be used kind of interchangeably. All right. And so what you should see here, again, if we scroll up, you should see pretty much the same parameters as in your your original common fate model. So if you're getting things that are vastly different, that tells you that there might be an indicator that there's some problems. So we have around 0.86, 0.80, 0.71, 0.75, and 0.405, 0.41. And so again, you see a little bit of a shift. It's potentially probably only due to like a rounding error in the estimation. And so really you're not gonna see things be a whole lot different. There's gonna be a little difference because again, we're constraining those residual covariances to be equal now. So you will see a small shift, but generally if you see a large shift, that means that your residual covariances cannot be constrained to equality, and you'd have a really bad fitting model, and your chi-square difference test will be significant. But in this model, again, you're not going to see a whole lot of difference. And you can see here, we have psi and psi. This is a good way to check to see if your syntax is correct. And your unstandardized output are the same. All right, so your standardized are always going to be a little bit different. So when you are constraining things, it's always in the unstandardized estimates. Likewise, down here, we have our labels, tau1 and tau2. And as you can see, our unstandardized means are constrained to be equal across dyad member, which again tells us that these are indistinguishable and our syntax is correct. And so finally, I'll point us down here to the very bottom where we have our chi-square difference test. And as I expected, and as I stated earlier, we added 3 degrees of freedom. We added 1.19 to our chi-square, and the p-value for that is 0.75. So again, this provides, again, empirical evidence that although our dyad members are theoretically different, male and female, within the current sample, they can actually be treated interchangeably where it doesn't matter how we organize people. We could have, for dyad member 1, we can have some males and some females, and the same thing for dyad member 2, and it doesn't really matter, all right? We can kind of interchange people, right? So that is how you test indistinguishability within the context of the common fate model. Hopefully that's been helpful in helping you better understand theoretical distinguishability versus empirical distinguishability, and it allows you to run these analyses in your poster presentations and in your manuscripts, because again, I very rarely see distinguishability tested, especially within the common fate model. So hopefully this has been helpful, and let me know if you have any questions.